Hey math friends, this is Precalculus section 6.2 day 2 notes. We have a short one today. We're just going to be going through a couple of examples of some word problems, but never fear. These are basically just some SOHCAHTOA problems. The most challenging part is understanding how to draw the picture based on the information that's given in the problem. But once you have your picture drawn, you're just going to be using SOHCAHTOA to solve for whatever it is that you are trying to find in the problem. Before we begin, there's two things that you need to understand. That would be what it means when the problem says angle of elevation, or what it means when a problem says angle of depression. An angle of elevation is the angle formed between the horizontal line of sight and an object above. So if you are looking straight ahead, and then you look up, right? So you're creating an angle there between straight ahead and looking up. For example, the angle created when a woman spots a cardinal sitting on the top of a building. The opposite of that would be an angle of depression. This is the angle formed between the horizontal line of sight, so again, looking straight ahead, and an object that is below you. An example here is the angle that's created when a teacher is looking down at a student that is seated in a desk. So for our first example, it says from the top of a lighthouse 20 meters high, a sailboat is sighted having an angle of depression of 4 degrees. Okay, so this isn't the best picture here, I apologize, but if we look here, oops. If we look here, here's our horizontal line of sight going to the top of our sailboat there. And then we know that our angle of depression, looking down at the boat right here, again, drawing not to scale, this angle right here is 4 degrees, okay? And we also know the height of the lighthouse right here is 20. What we don't know and what we're trying to find is the distance from the lighthouse to the boat. However, this does create for us a right triangle, we can see in our picture there. And we know some information here. We kind of put that in as a dashed line. The lighthouse and the line that I just drew are two parallel lines. So if we think of the hypotenuse of our triangle as being a transversal that is cutting through those two parallel lines, then that tells us that this angle right here in my picture is also a 4-degree angle. So if we know that, we have everything that we need to know to solve this problem, because now we've got an angle, a known angle in our right triangle, and we have a known side in our right triangle. And as long as we know an angle and a side, we can find anything else that we want to find. Since we know the angle 4 degrees, and we know the side opposite is 20, and we're looking for the side adjacent, we want a trig function that uses opposite and adjacent. We know that that trig function is going to be tangent. So I am going to say that the tangent of 4 degrees, whoops, degrees, not 40, sorry about that. The tangent of 4 degrees is going to be equal to the side opposite, which is 20, over the side adjacent, which is d. And if I rearrange my equation to solve for d, I'm going to get d is going to be equal to 20 divided by the tangent of 4 degrees. Now you grab your calculator, make sure you are in degree mode, and we get the distance d is going to be equal to 286, and we have to think about units in our problem. The lighthouse was given as 20 meters high, so that means that our distance is going to be 286 meters away. Example 2, it says when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. How high is the building? All right, so let's add a little bit of information to our picture here. We know that the shadow that is cast by the building has a length of 45 meters. So we have a shadow here from our building that is 45 meters. Okay, and we know that the sun's angle of elevation is 38 degrees. So we know that this angle right here is 38 degrees. Our job is to find the height of the building. So right here, our job is to solve for h. But we know that this is a right triangle, right? Because the building and the ground where the shadow is are going to create a right angle. So again, we know the 38-degree angle. We know the side adjacent is 45, and we want to know the side opposite. So once again, we are going to be using tangent to solve this problem. Tangent of 38 degrees is going to be equal to the side opposite, which in this case is h, over the side adjacent, which is 45 meters. Rearranging our equation, solving for h, we're going to multiply both sides of the equation by 45. So h is going to be equal to 45 times the tangent of 38 degrees. You grab your calculator, make sure you're in degree mode, you type that in, and you end up with an answer of h equals 35.2. And again, units in this problem, if the shadow is casting a length of 45 meters, that means that the height of our building will be in meters. The height is 35.2 meters. In our final example today, it says a 530-foot guy wire. A guy wire is basically a wire that attaches a tower to the ground. So kind of the hypotenuse of our triangle here is our guy wire, okay? It says a 530-foot guy wire, so I'm going to add that into my picture here, is attached to the top of a 155-foot tower. All right, so we know that the height of our tower here is given as 155 feet. So here's our right angle in our picture right here in the corner, okay? And the question is, determine the angle the wire makes with the ground. So this one is a little bit different. This time, they are tasking us to find theta, okay? Well, if we look at our picture, we know the side opposite of theta, and we know the hypotenuse. So we want a trig function that uses opposite and hypotenuse. That's going to be sine. The sine of theta is going to be equal to the side opposite, which is 155, divided by the hypotenuse, which is 530. So theta will be equal to inverse sine of 155 divided by 530. And again, you want your calculator to be in degree mode so that we can find our angle in degrees here, our angle of elevation, right, of the wire, or depression, I guess, depending on the angle that you're looking at it. And we type that into our calculator, and we find that theta is 17 degrees. And that's it.